I'm going to be taking a look at the Fall 2016 final exam. This is question 7. On this particular question, we're asked to come up with the third order Maclaurin. So again, we're doing a Maclaurin. We're looking for the third order Maclaurin, and we're looking for the function, looking for the Maclaurin for the function. We're going to do the cube root of 1 minus x, and we're limiting our x so that it's greater than or equal, greater than 1. Okay, we don't want this to be a 0 because we're going to have to take derivatives on here. Okay, so the first thing I'm going to do is I'm going to rewrite this to be 1 minus x to the 1/3 power. Okay, so we know we're going to need to be able to take derivatives. Okay, so let's write out our format for the Maclaurin, our general format for the Maclaurin. So our third order Maclaurin polynomial looks like I need to take my function, evaluate it at 0, because that's what Maclaurin is. I have to take my first derivative, evaluate it at 0, and multiply that by x prime. X to the first power, not x prime. X to the first power. Let me actually get rid of that so it's not confusing. I need to take my second derivative, evaluate it at 0. It's going to be x squared divided by 2 factorial. And I have to take my third derivative, evaluate at 0, times x cubed divided by 3 factorial. These derivatives here in the function, right, this is our 0th derivative, these derivatives here all tell us the coefficients, okay, for these portions of our Maclaurin polynomial. Okay, 2 factorial, 3 factorial also form part of our coefficients. Okay, so the first thing that we need to do is we're going to set up a table where I have my function. I need to give myself space. My x is equal to a, which is equal to 0. Okay, so it's Maclaurin. Right, so we're saying we're going to evaluate each of these. We're focusing our polynomial around x equals 0. So the first thing I'm going to do is f of 0. Okay, so actually f of x is equal to 1 minus x to the 1/3. And I'm going to evaluate this function at 0, which is equal to 1 minus 0 to the 1/3. 1 minus 0 is just 1, to the 1/3 is equal to 1. Okay, so our first coefficient is equal to 1. This number here is going to go in here. I need to take my first derivative. Just don't forget your chain rule on here. And so I've got my exponent, so I'm going to go 1/3, 1 minus x. I have to subtract 1 from here, so I'm going to get minus 2/3, and I have to do chain rule. So the derivative of minus x is equal to minus 1. Okay, we have to evaluate this at x equals 0. That's our Maclaurin. So I'm going to go minus 1/3 times 1 minus 0. 1 to the minus 2/3. So this is equal to minus 1/3. Okay. My second derivative. Okay. I'm going to take my exponent, multiply it by the coefficient that's there. So I'm going to go minus 2/3 times minus 1/3. I'm going to do this multiply through. And then I need to 1 minus x to the, I have to subtract 1 from here. So I'm going to get minus 5/3. I have to take again the chain rule, which says this is equal to minus 1. Minus, minus, minus. So keep that in mind when you're actually calculating out. Okay, I'm evaluating at x equals 0, so I'm going to get minus 2/3 times minus 1/3 times minus 1 is going to give me minus 2/9, okay, times 1 to the minus 5/3, which is just going to give me minus 2/9. Okay, so this coefficient here is going to go in this portion of our polynomial. Our third derivative, okay, I take my exponent, minus 5/3, multiply it by what's there, minus 2/3, minus 1/3. I've got this minus 1 here from before, and I've got 1 minus x to the minus 8/3. Okay, and then my chain rule says I got to do minus 1 from before. So that's why I moved this minus 1 out here, so I don't confuse myself and think, oh, I've already done it. Okay, so now, right, I'm going to take my third derivative, evaluate it at x equals 0. Okay, so I've got minus, 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 4 minuses, but I've got a 5 minus. Okay, so this is still going to be negative. It's going to be negative 5 times 2, 10, 3 times 3 times 3, 27. Okay, times 1 to the minus 8/3. So we're still looking at minus 10/27. So this here, right, is going to give us this coefficient right there. Okay, while we're here, let's come up with our nth derivative. Okay, so I'm basically looking at, actually, well, let me take a look. So we need to do, later on, part B says we need to come up with a reasonable error, okay? Actually, part B or part D, I can't remember. Yeah, it's a reasonable error. Okay, so that means I'm only looking at the fourth derivative. So I'm only going to go up to here. So my fourth derivative says I'm going to go one more. Okay, so the fourth derivative says I'm going to go minus 8/3 times a minus 5/3 times a minus 2/3 times a minus 1/3 times minus 1 times minus 1, so that would be positive 1, and minus x times minus 11/3, and then I do the chain rule again. Okay, so this is the form, let me just write it out here. So this is minus 81, I'm sorry, minus 80 over 81. So this is 5 times 2 is 10, times 8 is 80. So minus 80 over 81 times 1 minus x to the minus 11/3. Okay. And it's minus because 2, 3, 4, 5. I've got like an odd number of negatives. So just this minus right there. Okay, so that's, I'm sorry, you can see that. That's our fourth derivative. Okay, we're going to need that when we actually go to do our error calculation, so I'm not going to worry about that for now. These here are going to form the coefficients for my Maclaurin. So let's write that out. So the answer part A, I'm looking at f of 0 evaluated 1, f prime of 0 minus 1/3 x, double prime minus 2, 9 x squared over 2 factorial, plus minus 10, oops, sorry, yeah, minus 10, 27 x cubed over 3 factorial. You can leave it like this, it's totally fine, okay? But you could also multiply everything through and get 1 minus 1/3 x minus 2 over 9 times 1, oh, sorry, let's go and do this, 2 over 18. Minus 10 over 27 times 3, oh, 3 factorial, sorry. And this is going to be 10 over 962 x cubed. But you could totally leave it like this, and that would be totally fine. So don't worry about actually multiplying things through if you're not sure. Just leave it. When in doubt, just leave it there. Okay, so that's part A. So part B says, use your answer in part A. Part A to estimate f of minus 0.1, which is equal to the cube root of 1.1. Okay, so they're kind of giving you this, but they're telling you what x is equal to. So my x is equal to minus 0.1. Okay, and then we want to be able to find a reasonable upper bound. And E2. Because we're basically doing part B and part C, like we did in other exams. Okay, so this first part here says I'm going to plug minus 0.1 into my equation here. Okay, so when I go ahead and do that, I'm going to get 1 minus 1/3 minus 0.1 minus 2 over 9, 1 over 2 minus 0.1 squared minus 10, 27 times 1 over 2 factorial minus 0.1 cubed. Okay, when I go ahead and multiply everything through and then add it up, be very careful when you do that so you don't make a silly mistake. You get 1.032284. And let's just check it real quick. I'm going to check it on my calculator. You can see that. So I'm going to go, 1.1 raised to the 1/3 part. That's taking the cube root of 1.1. I'm going to get 1.0322801115. So we're in the right ballpark in terms of answers, okay, from what I got on my calculator, right? I'm just plugging it in, and then from actually doing this, that kind of gives me a clue that maybe, I did the Taylor expansion correctly. Okay, so then the next part says, let's come up with the error. So my error calculation. Okay, so for this part, remember we need to do max f of n plus 1 of z. So how we calculate z and how we calculate this f of n plus 1 times, right, this is the Maclaurin. So I'm going to go x to the n plus 1 and over n plus 1 factorial, okay, which is max of my fourth derivative evaluated. So you have to figure out what I'm going to do for z. I have to evaluate x to the 4 all over 4 factorial. Okay, so this part here I need to think about. Okay, so now let's take a look and think about where we're going. So we were told that we wanted to find Okay, so we actually, when they gave us, let's see this part right here. When they gave us this, that kind of gave us a clue. We're accustomed to seeing things like absolute value of x is less than or equal to 0.1. Okay, but when they told us to evaluate x is equal to minus 0.1, what we're really doing is we're setting up a bound, kind of like this. Okay, so this x value that they gave us was a clue for how I'm going to set this up here. Okay, so now how do I choose which end to do? Okay, but what I want to be able to do is take a look. Actually, what I'm going to do is I'm going to set this up as minus 0.1, and it's just between z, right, where I'm evaluating x and a. So my a value is actually equal to 0. So I'm going to restrict this to be equal to here. This is my a value, and this is my x value. Okay. So I need to choose a z value on here that's going to maximize that. So I look back at my derivatives, right? So my derivative is of the form, right? I've got some number, right? That's my coefficient number. And this is all over 1 minus x to the 11/3. Now, if I'm not sure what this function looks like, 1 over 1 minus x to the 11/3, I'll use my graphing calculator to see. I hope you guys can see that okay. I plugged in 1 over 1 minus x to the 11/3 in my graphing calculator, and I hit graph because I want to see what it looks like. And I kind of zoomed in. My window is set to -1 to +1 on the x, -1 to +1 on the y, because in theory, I'm only looking at this tiny narrow border right around x equals 0. But look at what's happening. Within this region, the function is an increasing function, right? My derivative is an increasing function. So because it's an increasing function, you need to choose the upper bound on here. So my derivative, this is, I'm going to call it, my first derivative is minus 80 over 81. The absolute value of that, 1 over 1 minus x to the 11/3 is increasing. So we're going to choose a z value equal to the upper bound, choose z equal to 0. Okay? So which means basically, right, I plug 0 into here, right? So my error calculation is going to look like max of the absolute value of minus 80 over 81 times 1 over 1 minus x to the 11/3, 0.1 to the 4th over 4 factorial. This is my error calculation right here. So you notice I've got an absolute value, and here's this negative part I'm not too worried about. My z, I'm going to plug in right up here. I'm going to, let's make this, instead of x, I'm going to call that a z, because it's really what I'm doing. Okay, so the z that I chose, 1 minus 0 is going to make it 1. So this whole thing here reduces down to 1. Okay, so I'm looking at my error is 80 over 81 times 0.1 to the 4th all over 4 factorial. And I just plug it into my calculator. And I get something along the order of 4.115 times 10 to the minus 6. So 56. Okay. And that's your error calculation. And that's 2016, the final exam question number 7.